Welcome to today's webinar in our series on the future of AI in education and training. I am Lewis Johnson, the overall host of the series. I'm very pleased to have today Professor Carolyn Rosé from the Language Technologies Institute at Carnegie Mellon University. Carolyn has done very important work in AI in support of collaborative learning. She and her students have done research in understanding how collaboration can make learning more effective and how AI can make collaborative learning more effective. And lately, she's been looking at how collaboration technologies can support teamwork. And this can have impact in the workplace where teamwork and team learning can synergistically help people to develop skills on the job. I think it has very interesting potential. So thank you for joining us today, Carolyn. We look forward to your presentation.
Great. So thank you so much for inviting me here to talk about this work. So let's go ahead and get started. So all of us have heard recently some statistics as more and more automation is out there in the world. And the landscape of work is changing. The need for people to keep up and to stay educated and to increase their level of education has increased. And so we see scary statistics like that up to 5 million jobs may be lost to disruptive labor changes by 2020. And we see this as, you know, what AI is kind of doing to us. So this kind of ominous picture sometimes settles in, and there's a lot of fear about that and resentment even. And you can see that in some of the responses even recently in the news. And so there can be kind of this feeling of doom and gloom. But in this talk, I'm going to talk a little bit more positively about the role of AI and automation in increasing opportunities potentially for people to keep their jobs and to stay educated and keep up with the changing landscape of work. But I'm not going to frame technology as a solution in itself, but more as a partnership between technology and humans. And so if you think about the landscape of educational technology, now there's a very vast and broad assortment of lines of research in that sphere, but I'm going to focus specifically on computer-supported collaborative learning. That's the area that I'm coming from. Some of you know that many, many years ago, maybe a couple of decades ago, I was doing work in tutorial dialogue systems. And at that time, I was working towards using dialogue technology to be more in the tutor role. That agent was what was delivering the instruction. But over evaluations, I got the sense that that wasn't where the most strategic angle was going to be for this technology. Because no matter what we do to make our dialogue agents more and more sophisticated, for the kinds of interactions around learning that I'm interested in being able to foster, the richness is so much easier to get between humans, and it seemed much more strategic to use dialogue agents to structure interactions between humans. So really for the past decade and a half, my group has focused almost exclusively on computer-supported collaborative learning, where dialogue agents that technologically are very similar to what we use for tutorial dialogue are now used in the midst of group collaborations. Now, in this particular talk, what I want to do is focus on where I think we can go. I want to talk about some work that's really just getting off the ground and that we've been doing probably really just formally for about 6 months now. So I'm going to, at the end of this talk, when I'm really focusing on the new stuff, I'm going to talk about some pilot studies, but they're not going to be yet, home runs. They're going to be things that we're still working on, things that we're working towards achieving. But I'm going to start by kind of laying a foundation in work that we have already accomplished, some results that we already have, resources that exist that we're building on in this new work. So I cite very frequently the work from my former PhD student, Rohit Kumar, from 2007, when we ran our first study using tutorial dialogue agents as dynamic support for collaborative learning for sophomore thermodynamics. And here you can see the client interface for this collaboration environment. It doesn't look so beautiful, but it, you know, it did the job. And so you can see here on the left-hand side, there was a shared whiteboard where students could share images from the simulation environment they were each running locally. They were working to design some power plants. They were negotiating over design principles. They were building on theoretical knowledge that they had learned already in that sophomore thermodynamics class. On the right-hand side was the chat. They could talk together about their ideas. They could, again, negotiate about the design. So they're talking about the images they're each pasting into the whiteboard. But in the midst of that chat conversation, you see some lines that are labeled tutor. That was the tutorial dialogue agent. And in the initial study that we ran, it still behaved very much like the tutorial dialogue agents that taught individuals. It was there to enrich the reasoning in the conversation. It was leading students through directed lines of reasoning that would help them to tie their design ideas back to the theoretical knowledge that was being taught in the class. And in this foundational study, we compared students in 4 conditions: students working alone with no support in the environment, students working with a partner student but no tutorial dialogue agent, students working with only the tutorial dialogue agent, and students who had both. And what we found was that students did about as well, and when I say did about as well, I'm talking about their pre to post test gains, when they had either just a fellow student or just the conversational agent. And that was about 1 letter grade, better than the control condition where they had neither form of support. But when we put the 2 forms of support together, there was a synergistic effect. There was a better effect in having both forms of support than having just one. And what that shows is that they're not redundant forms of support, but they're providing different support. That we needed to have the scaffolding of the agent there. It helped the interaction go better. But the fellow student, even just having another student there to do the activity with, was also valuable, and just as valuable as the carefully crafted tutorial dialogue agent that we had used in prior studies that were actually aimed at individual learning in the same domain. So after that time, we continued to explore the idea of using dialogue agents to support collaborative learning. And again, we see early on, just validation of the idea in general. But over the years, we've done slews of these studies in classrooms of different levels. And looking at forms of support that take very different strategies, that look very different, that kind of focus on different issues, and yet at their core are still working to enrich the depth of the conceptual discussion that's going on. So sometimes we might directly scaffold the kind of reasoning that students are discussing, and that was very much of the flavor of the original study where the tutorial dialogue agent was really focused on directed lines of reasoning. But later we might focus on such issues as things like breaking the tension within the group, making the agents more sort of personalized and kind of jokey to release tension and make people feel more safe with each other, or social strategies that directly talk about ways in which to make the students help each other feel more safe in that environment, or that the agents would model a kind of open style of communication that increases safety and then was associated with more articulation of reasoning, more building on reasoning. Or even accountable talk agents. There was, for many years, work where what we did directly was to use classroom facilitation techniques that we were also involved in training teachers to use, that directly focused on drawing out reasoning and getting students to listen to one another. And more recently, we've been working with software teams, we focus more on roles within the discussion. Now, these things all look very different, even though we use conversational agents in all of these cases. But really the idea is to create an environment where students are having a rich conceptual discussion. And it's the rich conceptual discussion that's most directly related to their learning. However, you can get to that state through many, many different paths. Now, we've done these studies across age levels in different kinds of school districts and in different subject domains. And very recently, you may have heard about some of our work in the massive open online course space as well. Now, currently, as I mentioned, we're thinking about the problem of the changing landscape of work and the increased need of people to keep up with increasing needs to become more and more expert in different areas, keeping up with automation, keeping up with the changing, just what's out there and how things work. And most recently, I think there was a lot of hype in the space of MOOCs as a potential solution to the need for education and for a potential for actually providing broad resources to, because it was free, it was going to be all about equity. And I'm sorry to sound a little sarcastic. I think there's a general disappointment in that area, but I was very much active in that area and trying to find a way to apply the research that we had done to that space. But ultimately, I think that that fad has more or less passed, and we wonder now, where does that leave us? What have we learned and how do we move on from here? So in the remainder of my talk, what I want to do is to talk, first of all, why is it that MOOCs were not the ultimate solution? So what do we learn from this that we should avoid going forward, and how do we take the next step? And how might collaborative learning be injected into the workplace? Can we find a different solution where workers can learn together in a way that contributes towards their work? And finally, I'll finish with some resources and opportunities for many of you out there to collaborate with us going forward. So it's no surprise, many of us have heard the stories that about MOOC attrition, that across courses, regardless of topic area or who was offering the course, the fact of the matter remains that by week 3, almost everyone drops out of a MOOC. Very few people actually finish them. Well, number-wise, there might be hundreds, but it might be a very, very, very small percentage of those who actually start. And the truth is that it's just extremely hard, or the majority of people who would like to make use of MOOC resources find it extremely hard to stay committed, to stay consistent, to follow through. They may show interest in the beginning, but ultimately you can see here the trend. It's just very clear. So in our work, we sort of fit into the landscape here in trying to find a way to introduce social support to increase commitment. There had already been quite some research in the area of online communities that shows that social interaction and social support are associated with increased commitment to online communities. And we saw MOOCs as being a new kind of online learning community. And could we then apply similar ideas in this space? And so in particular, we worked with some courses, and this slide here that you see is from one of our partnerships with a medicinal chemistry MOOC from Davidson College. And we ran a series of studies in the midst of this MOOC where we introduced collaborative reflection activities. And the way it worked was, at the end of each unit, there was an opportunity for students to engage in a collaborative reflection activity by pressing a button and entering a room in which a dialogue agent would lead them through a reflection on the concepts that were introduced in the unit. So it was up to the student to decide to do that activity. And when they came in the room, there would always be the conversational agent. But sometimes there would be another partner student there to have the discussion with, and other times it was just a discussion between the student and a conversational agent. So we could then measure the impact of having gone through that activity with another student present. So here in this flow chart, you can see that at the first choice point, students decide, am I going to click or not? And at that point, we can separate students into two piles and see what is the probability of dropout by the next point, given that they clicked or that they didn't click. And at that point, what we're really measuring is, you know, how committed was the student anyway, that more committed students you would expect to click that button. But then we can also, beyond that, given that a student clicked, was there another student present? And so we can compare probability of dropout if a student was present with probability of dropout if a student was not present. In that case, we're already controlling for the choice of the student, because in both cases, the student made the same choice. And then it's just not under the student's control whether there would be another student there for them to engage in the activity with. So what did we find? We found that the level of, that the probability of dropout by the next time point, if they clicked or not, was the same as the level that we observed if they clicked and there was no student present. So just average level of dropout as we observed in the class. But if they clicked and another student was present, we observed a 70% reduction in the probability of dropout before the next time point. And in that case, we were really isolating the effect of having gone through the activity with another student. So there was a powerful effect of having gone through the reflection with another student. Now, we ran the study under similar conditions across multiple classes, in every case observing significant associated drops in probability of dropout by the next time point from having experienced a collaborative chat with another student. However, a 70% reduction in probability of dropout by the next time point doesn't mean that a student, because they had this chat encounter with another student, is going to finish the course or finish the course successfully. In the end, we managed to slow students down in their process of dropping out, but largely students still did not complete these MOOCs, and it really didn't solve the problem, even though it reduced the problem. And so we turned to something much more extensive. What if we really changed the whole nature of courses to make the whole course experience more social? Team-based learning was something that in the beginning of MOOCs, there was a lot of doubt whether we would really be able to support that kind of thing. There's a lot of orchestration that goes into large-scale collaboration like that would be difficult to do in MOOCs, and that was an active area of research. There's also the question of whether students come to MOOCs really looking for that, or whether they really want the solitary experience, even if the solitary experience can be problematic from a motivational standpoint. But there are lots of reasons to value team experiences, and any of us who teach in universities, especially in technical fields, we have these group projects and capstone courses where students work in groups. And why do we believe in doing that? It's because we know that in teams, students can accomplish large and complex goals that individuals wouldn't be capable of, that it's highly motivating, that students actually do largely like that, although sometimes students will complain about bad experiences they've had in collaborations in the past. They learn from one another. And also we need students to learn how to interact in teams, because in the workplace, oftentimes work is done in teams. So there's a lot of reason to want to develop technology that would make it possible to have these team-based learning experiences, beyond just the hope that maybe a team-based MOOC would be more effective. But in fact, there was a platform that started out being the social MOOC platform. It shifted away from that after a while. And it was a struggle for this NovoEd platform to offer team-based MOOCs that were effective. And we were very fortunate to have the opportunity to partner with them at a certain point, and they were kind enough to share with us data from a couple of classes. And what we observed in the data that we that we collaboratively analyzed was that 87% of the teams failed. Now, initially we thought, okay, it's a team-based MOOC platform. We're going to take all of this research we've done on supporting teams and structuring team interactions, and we're just going to see how does it do in this environment. But as we looked at the data, what we saw was the problem was happening even earlier than that. The teams were failing to get off the ground from the beginning. And the paradigm that was being used for orchestrating these teams was that students would come into the MOOC, they had to immediately self-select into a team, and then they depended upon their team for all of their interaction for the remainder of the course. And students didn't have a good basis for assigning themselves to teams early on. And so many times they would pick a team for reasons that didn't end up working out so well in terms of having the chemistry and the interest and the ideas to really get a project off the ground. So we decided to draw from a concept, a conversational construct called transactivity. And yesterday when I gave a version of this talk, there were some questions about, does it have to be transactivity exactly? And what about other frameworks in the learning sciences that seem to draw on similar principles? So in our work, we have done a lot of work with transactivity, but the reason why we picked it was because it was really one of many ideas that were very similar, that it seemed like if you look across frameworks for characterizing what is valuable in collaborative interactions, almost everyone's work includes some dimension along which they're focusing on the extent to which students are articulating their reasoning in ways that show an awareness that there are different ways of viewing it, something, and that they're connecting their ideas to the ideas of others, and that's a sign that they're open to evaluating their mental models in connection with other people's mental models, with the opportunity in that comparison to experience a cognitive conflict and ultimately work out the search for a new way of thinking about something. And that way of interacting is associated with learning. And you can call it lots of different things. You can explain it within different theoretical frameworks for understanding learning. And yet it seems like this idea of articulating reasoning and building reasoning on reasoning is like the DNA of a well-functioning group. So I've mentioned that the key component of transactivity, what's really important here is that we want students to articulate their reasoning. We want to connect that articulation to ideas expressed earlier in the conversation. This signals interest, respect, solidarity. So there's really a cognitive side of this and a social side of this. Now, normally, the goal of the focus is to get more transactivity and to think about it as an explanatory variable. It's a process variable that explains why an experimental manipulation in a collaborative context led to more learning or better work or knowledge transfer. But in our work on group formation, we sort of turned it on its ear. And now we were saying, okay, actually, when we see transactivity, it signals that something is going on the social level that creates the environment where this kind of flow of reasoning is occurring. And so if we can see that spark, we can predict that that pair that exchanged transactively would work well together in another context. Now, as far as I know, our studies of this were the first studies of how transactivity transfers between contexts, but based on all of the theoretical underpinnings, it makes sense. Here's an example conversation from a paradigm we used in several of our studies of transactivity, where groups were working together on designing a power plan for a city. And so that involved bringing in expertise about different forms of energy for a city and thinking about the characteristics of cities and what would make a good way of powering that city. And here in this conversation, which was a thread from a discussion forum, you can see that four students are talking to each other, contributing their ideas, and in particular, student 4 is articulating reasoning in a way that connects to prior ideas mentioned on that thread. So it has the ingredients that we expect to see. So we designed a new paradigm for team-based MOOCs, that instead of students joining a team immediately, we would start out by building some individual expertise in students and then have them share that individual work in a community context, like a discussion forum, and give them the instruction to give feedback to 2 or 3 other students of their choice. And then we would observe the level of transactivity between each pair, where there was any kind of an exchange. And then we would get a read for some pairs within the community of collaboration potential. Then with those signals in mind, we used an approximate constraint satisfaction algorithm to do a maximization over the whole class to be able to assign the students in the class to groups of 4 in such a way that if we averaged across the formed groups in a class, the level of pairwise predicted collaboration potential within groups, it would be maximized on average across the class. So what that means is that everyone in the class, regardless of what they did, who they talked to, and what the observed level of transactivity was that we saw, they would be assigned to a team. But which team would they be assigned to? In this approximate constraint satisfaction approach, we would search for a solution in which it was more often the case that the group a student was with were the people who they had shown the most of a tendency to interact transactively with. So we used that paradigm you do an automated transactivity analysis over the discussion forum data, do the constraint satisfaction to assign students to groups. Then they would be in those teams and they would do their project. And in some of our studies, we also offered additional scaffolding for group processes during their group work using the work that we had done previously. So it was important to be able to do the transactivity detection automatically. And we've been doing transactivity detection in many studies in our past work. But most recently, my PhD student, James Fiacco, has been working on some deep learning approaches that build on top of recent work in language technologies on entailment detection, because entailment is a kind of inference that occurs in language. And so a model that's been trained, especially with a really large scale data set that cuts across multiple domains, is going to have a representation of the space of ideas that could be leveraged in being able to make connections between articulations of ideas in one turn and those that have been expressed in previous turns. And we've had automated models for transactivity detection for over a decade now that worked very well, but they were usually very domain dependent. But this approach that James worked on was a domain transfer approach because it built on a foundation that was designed for that. This Fiacco and Rosé 2018 paper was published at Learning at Scale last summer, so that paper is available online. But this paper that's cited at the bottom was the work that we were building on. That was work that was published at the Empirical Methods in Natural Language Processing Conference in 2016 on entailment detection. We used a very similar architecture, we just modified it slightly, and we used as a pre-training task the same corpus that they had used for entailment detection in that work. So doing an automated transactivity detection, we can build on top of that and then use our approximate constraint satisfaction algorithm that I pointed to earlier. The specific one we used, it's actually very simple, minimal cost network flow. The idea here is that an exhaustive search across all of the ways of assigning students to groups would be prohibitively computationally expensive. But using this constraint satisfaction algorithm, we're able to do the search very efficiently. And we may not end up with the totally optimal solution, but we end up with a solution that's good enough. It's better than random. So in this particular case, what's nice about this algorithm is that we can also enforce more than one constraint at a time. So in the course, the students do some individual work. And so if we assign students to different conditions where they're becoming expert at different things, then we can use this constraint satisfaction approach to say, okay, I want in every team somebody from each of the 4 areas of expertise, but to do it in a way that also maximizes this transactivity constraint. And then we would check. So we ran, to validate this approach, several studies in Amazon Mechanical Turk in a simulated class so that we could look at, how big does the population of students have to be in order for when we do this transactivity maximization with the constraint that we also want a student in each group from each of the expertise, we still end up with a solution that gives us an elevated level of average predicted pairwise transactivity over random. So that was the first challenge. That was the technical challenge. But then, of course, we wanted to test to see if in doing this, in fact, we would get teams that performed better, or that were set up for better success. So in these simulated courses, we would run several rounds of our simulated course, sometimes where we would enforce this transactivity constraint, and other times where we didn't enforce the transactivity constraint. And so then we would compare. When I say random teams here, those are teams where we still enforce the jigsaw constraint that each area of expertise was represented within groups. It was random with respect to transactivity, and in the transactivity maximization, we would enforce both constraints. And then the students, once they got into their teams, they did an activity where they were bringing their multiple sources of expertise together to design a power plan for a city that was more complex than any of the ones that they had looked at as individuals when they were just studying their own power source that they were responsible for. And so we looked then to see, how did that conversation go? So what level of transactivity was exchanged in the synchronous chat while they were working on the activity together? And then also, to what extent did they manage to come up with a power plan where they integrated those 4 forms of knowledge? And what we found was success on both fronts. So here what we see is that in the chats, we see an elevated level of transactivity exchanged when we use the transactivity maximization to form the groups. And similarly, we see more integration in the report that's produced by the teams when we use this transactivity maximization to form the teams. So once we had validated the approach in our simulated class that we could run as many times as we wanted in Amazon Mechanical Turk, we then ran this in a real MOOC, this time in collaboration with the Smithsonian Institute. So they had run this Superheroes MOOC 3 times previously as an individual learning course. And what we did collaboratively was to design the collaborative version of this course, where students who had taken any of the first 3 instantiations of the course in which they would have designed their own superhero were now taking this collaborative version in which they would work with other students to create a superhero team out of their individual superheroes. So they would have to come up with a story that involved all of their characters. So we invited the students from the 3 previous instantiations of the course. 770 students signed up. Now, as usual, more students signed up than students who actually actively participated in the course. So in the first week of the course, 208 students actively participated by posting something about their individually created superhero to the discussion forum, and they were asked to give feedback to 2 or 3 other students of their choice. Then we did an automated transactivity detection over the discussion forum and assigned 52 teams of 4 students each. All 52 of those teams turned in a project at the end, and we performed correlational analyses of their group processes and of their results to check to see if the predicted level of of collaboration potential from the transactivity analysis would have the same relationships within this data as we saw in our experimental studies, and in fact, we did see that. However, although this seems like a success, we still didn't feel like we solved the main problem with MOOCs. The fact of the matter is that life gets in the way. Whenever somebody has to go somewhere else out of their usual routine to learn something, it's just very difficult, especially when we're talking about populations of people who are working full-time, largely having family responsibilities as well, not really having the support during the learning that you would have, in an in-person learning kind of a situation. And so that's where we turn to this idea of bringing the learning into the workplace. Now, this is where I'm going to start to get into work that we're just beginning to do now. And we still have a lot of questions that we're answering. And so really this is just a cutting edge work that we're doing, not finished yet, no home runs yet. We're still working on it. But I want to share with you the questions that we're grappling with and the work that we're doing, actually in hopes that we'll inspire some people to join us and to do similar work, because I think this is really where the impact is going to be. What we would like to see is that in the workplace, though understandably, the focus really is mainly on efficiency and productivity and getting something out there that's going to make money for the company. The truth is that many companies, actually even well-meaning companies, even offer opportunities outside of work for people to go and get continuing education. But oftentimes this focus on productivity and efficiency undercuts that when push comes to shove, people don't often have the opportunity to take full advantage of those offerings. So what we'd like is to be able to restructure how work is happening and also give more insight into the trade-offs between learning and productivity in group work settings in the workplace, so that intentional decisions can be made to make small short-term sacrifices in productivity in order to achieve longer-term gains in productivity from people having the opportunity to learn as a normal course of how they're doing their work. So what we'd like to see is people working in diverse groups so that each member can learn and teach while doing work, to create opportunities for individuals to perform tasks that they're still learning, which isn't how we usually do our work in the workplace. Usually we do what we're good at because we're going to do that better. But can we make opportunities where people can practice, where there are people around who can mentor them? So there's scaffolding for learning and performance in situ. That's the vision that we have. So what we're doing is we're leveraging an emerging paradigm for software development coming out of industry called mob programming. Some people think of it as pair programming on steroids. It's the idea that teams of software developers will get together for joint software development where they rotate in their roles. And so one person at a time is in their driver's seat where they're directly interacting with the software. And then there's a navigator who's kind of directing what's happening and probably offering some guidance to the driver. But there's also the mob, and they're brainstorming, they're evaluating, they're offering ideas. And in this group then, there's kind of a shared cognition going on, where it's not on any one person's shoulders to drive forward the work that the group is doing, but they're doing it as a configuration across these roles. And the roles are rotating, so everyone has the opportunity to see what they're working on together from multiple vantage points throughout the session. Now, there hasn't been a lot of science behind mob programming yet. And to be honest, when I first heard about it, I couldn't believe that this is actually going on because it doesn't sound like it's cost effective. But some companies swear by it. They say the work is more continuous, that knowledge sharing is increasing, Coordination hurdles are being removed in software development processes. Individual weaknesses can be overcome. The perceived stress is decreasing. People are taking bigger risks and doing more creative things in their work. So we wanted to see, can we put a little bit more science behind this? Can we augment this paradigm to make it more imbued with pedagogical principles for learning? Can we study how learning is happening in these things? And then can we take an enhanced version of this and then bring it back to the workplace? So I'm working with two of my colleagues here at Carnegie Mellon University, Madge Saker and Michael Hilton. Michael Hilton comes to us from the field of software engineering, an expert in mob programming, having studied this in his PhD, but also having worked in industry. And Madge runs a large cloud computing course that is a distributed online course offered across all of CMU's campuses across the world. We have branch campuses, so Pittsburgh is not the only place where we have Carnegie Mellon, actually. So it's a very large class, over 100 students every semester, really hefty class, software development heavy, advanced concepts, really great fodder for discussion. So it's been great to collaborate with them, actually. And we've run a few studies in Madge's class, even before we started to play around with this mob programming paradigm. But the idea is that when Michael Hilton came and joined our group, he was very excited about putting some science behind the idea of mob programming. So we developed an online version of mob programming. We embedded it into the Amazon AWS Cloud9 software development environment, so an industrial strength software development environment, really hefty for doing large scale software. You can see on the right hand side a chat interface where students in the distributed team can talk to each other while they're working on the software. You'll see in there the OPE bot, that's our conversational agent who's structuring the activity, guiding students to change in their roles. And we've also added a new role to the mob programming paradigm called the teacher facilitator, who's kind of orchestrating the extent to which within this mob programming paradigm, in addition to working together to solve problems, that agent, that facilitator is drawing from resources that the group has for providing the conceptual foundation for the work that they're doing and injecting that into the conversation, raising questions, raising ideas, and trying to remind the students of what they should be learning in the activity, or what that they could be drawing on and thinking about and reflecting on in the work that they're doing. So in a recent pilot that we actually, we're still in the semester where this pilot is being run, but this part of the pilot is done now. 120 students were divided into unique teams of 4 or 5 at 3 different time points. What that means is we had this class of 120 students. Every student participated in a group at 3 time points, and each time they did, they were with different students within the class. And they didn't have a choice who they were working with. At the initial time point, they received training in OMP practices within this online mob programming environment. And then at the second 2 time points, they engaged in group work using this paradigm. So the correlational evidence suggested that the teams that adhered to the OMP paradigm, that followed the leading of the structuring that was provided through the conversational agent that would assign roles and tell them when to rotate and tell them which part of the activity they were supposed to be focusing on at a given time. Some teams were more compliant than others. Those that complied with the OMP paradigm, we saw engaging in role-appropriate conversational behavior. During the conversation, we saw more equal divisions of labor regardless of prior knowledge or skill, rather than students gravitating towards those things that they were already good at, and a lot of the work being shouldered by the more capable students, which we often saw in the non-compliant teams. And more time on concept-oriented reflection, and all of this with no decrease in grade or increase in time on task. So we see this as a step towards success, a glimmer of hope. We're still refining the paradigm. We're refining the design of our agents. We're looking at those conversations. We're instrumenting further to be able to also investigate learning gains that occur based on how students are engaging in these OMP practices. But at the same time, we also ran a pilot study with industry professionals where we made the materials from this cloud computing course available to industry professionals who wanted to learn more about cloud computing for free this past summer. Now, I should point out that the people from industry who used these materials really struggled with it. And what we realized was how difficult our materials actually are. And so one of the things that we feel that we need to do, at least to scale back the learning opportunities in cloud computing in particular, is really to break it down in a little bit more bite-sized chunks, and to realize that the students at Carnegie Mellon, by the time they take cloud computing, are really not your average software developers from industry who were interested in learning more about cloud computing. That was one of the things that came out of this that was really kind of orthogonal. I want to say that just because somebody yesterday noticed the statistics here. So it was this 6-week free online course with industry professionals. 130 signed up. 63 completed the course, and only 9 of them actually achieved a passing grade. It was just the material was too hard. But that didn't have to do per se with this mob programming paradigm. It was the material that they and the time that the course required that they weren't able to keep up with. But to the extent that we observed how they interacted in their mob programming groups, we were pleasantly surprised to see how well they cooperated with the paradigm, that they were willing to take direction from a conversational agent and in the rotation of their roles, and that although sometimes they did balk at giving a place to somebody to do a task that they were less capable of doing in the rotation of roles, by the end, many were making observations about how valuable that was and how great it was to see things from multiple perspectives. So we observed students taking up roles and transitions as instructed. 80% of the group activities were submitted successfully. Role differentiation made space for differences in expertise, and more so as the course progressed. And in future studies, we'll investigate more about the learning versus productivity trade-offs. So moving into the future, I think the theme that I've been trying to get across in this talk is to remember to use people as a learning resource for one another, that technology is a catalyst, and we don't want to remove the human element from learning. And maybe it was the removal of the human element or the reduction in the human element that made MOOCs a little bit less than what we had hoped they would be. So can we find a better solution? But it isn't even just the social aspect, though. As I said, it's more about where is the locus of the learning. And we want to bring this learning back into the workplace, because ultimately we don't believe that it works for people to kind of step out of their context and find a learning opportunity, because life gets in the way. And so we want to be able to use collaborative learning as a paradigm for learning during work. And so we're just starting to take steps in that direction and build on the foundation that we have. So I want to point out, only very briefly because I'm out of time now, that we've been developing resources in addition to doing our own research that we're happy to share with anybody who would like to do similar kinds of work or even partner with us. We have data infrastructure, learning analytics, and interventions that are enabled by those analytics. And this can be placed together within a pipeline that, that fuels the forward progress of this work over time. Ooh. Oh, yes. Okay, so I invite people to come to our dance website, dance.cs.cmu.edu. We have videos from an online talk series there. You can sign up to be part of that series. You can give a talk if you're interested. Also, we have resources, software resources you can get to. We've developed discussion forum software that with hooks for connecting intelligent interventions. We've got a text mining tool bench that's in very wide distribution, social recommendation software that can be configured in different ways for matching people into groups or to suggest opportunities for social engagement in discussion forums. DiscourseDB is our data infrastructure, and Bazaar is the architecture for using conversational agents as collaboration support. So thank you so much for joining in today. I've been very pleased to join in, and I'd be very pleased now to take any questions.
Great, thank you. So we do have some questions. So one question relates to the composition of the teams that you're studying and what's an optimal composition. You talked about the importance of diversity in teams, but presumably there has to also be a degree of parity amongst the team members. Otherwise, people aren't going to be contributing. So what's the optimal trade-off from your perspective?
Yeah, I think you're absolutely right. I think you're absolutely right about all of the issues that have to be considered. There's been a lot of research on group composition in the field of collaborative learning, and especially findings that are concernful that say when there's a lot of disparity in ability level between students, it can breed resentment, especially among the more capable students. And I think a lot of times when people complain about their group work experiences, it's where they were the more capable peer. So in our studies where we've kind of maximized diversity, what we did was we set every student up to have something valuable to contribute. And especially in the pilot study that we did in industry, we also saw this, that what mitigated some of the resentment was when students realized, like, oh yeah, this other person, they know less than me about this one thing, but they knew about this other thing that I didn't know about. And so when students have the opportunity to see an exchange, then they're very happy to work with somebody who is less capable on one front because they're getting something on another front. And so I think what we have to do is make sure that every student has something to contribute to a collaboration in order to make everyone feel like they do have something valuable, because I think nobody's comfortable when they're in a group and they're just, you know, they don't have a reason to be there.
Right.
And I think that that will be especially important in the workplace. But so how do we make that happen? I think that we have a lot of work to do on looking at how we can assign people to teams differently over time in a strategic way, so that each time they're assigned, they're learning something new and gaining some new expertise, and they're not a drain on that group. So it may be that people who are very low on the skill level will end up with people where, on average, the group that they're in is less capable, because there will be less disparity and nevertheless differences in terms of what they are good at. So we can bootstrap them up a bit and get them ready to engage with people who are at a higher level. It just might take time and multiple steps to get there.
I think related to that, so a suggestion here is that it might make sense to put this in the context of a competency framework, which is to say that different learners bring different competencies to their job, and they also are seeking to acquire new competencies. And then maybe you could compose a team both in terms of the competencies they have as well as the competencies that they desire to have, and that could actually be a good outcome of the collaboration.
Yeah, and in fact, so we use that all the time here in our capstone courses, especially in programs that are purposefully interdisciplinary, so that the teams can have people of different expertise. In those cases, though, what we normally do is have people playing the role that they're most good at. And what's different in what we're playing around with here is that we want to give people the opportunity to actually try something that they're not good at with the scaffolding of somebody who is good at it. And so that's really where these rotating roles within the mob programming group come in, because one person is driving, but that doesn't mean that that person has to be most expert on what they're driving at, because the navigator is there to offer scaffolding and the mob is weighing in. And so because of that, the thinking is really shared at every point. And so then it's important that they take these different roles, but then they also are expert at different parts of the task, not just expert at a role and not another role. The roles are actually just about, they're more like conversational roles, they're more like a form, but the substantive expertise, regardless of which role you're in, you have the opportunity to offer that expertise. And so we think that what happens is that these roles, they just get people to stop and listen to each other and help each other. They scaffold the listening, helping process, and also because they give you kind of a different view, that also enhances the extent to which people listen and realize there's more than one way of seeing the situation. But at every given point, there's an interdependency between those roles in driving the process forward. And so the hope is that in there, the multiple expertise also connects. We're still figuring it out. I don't think we have all the answers. What we've seen, though, looks pretty good in terms of how following the paradigm leads to more reflection and more connection between the students.
Great. So you focused on transactivity as a construct for determining, effective team collaboration. More constructs that are more commonly pointed to are rapport and trust. Mm-hmm. Now, maybe those are related. Maybe people who trust each other are more likely to engage in transactive interactions. Or maybe transactivity is the important thing, and it doesn't matter if people have rapport or trust. Could you comment on that, please?
Yeah, I think that that's actually a really great question, because I've had this discussion with some of my colleagues regularly, because I know that there's been research about the role of rapport and trust in learning. And my argument would be the reason why you see that correlation is because when you have those social constructs, it creates an environment in which the needed cognitive activities are more prevalent. So transactivity has sometimes been termed socio-cognitive conflict. And so it comes from this very Piagetian idea that you're more likely to experience a cognitive conflict when there's a balance of assimilation and accommodation. So that happens when what you're interacting with is something that you respect as having something potentially to say that's valuable in your mental model. So but you're not just abdicating, so you're not sort of just taking it all in. You're thinking of it critically with your own mind. This is a very Piagetian idea of how we reason and when we are likely to experience a cognitive conflict. So similarly, if you're in a social environment where you respect another person and are trying to build common ground, you're listening to them, then you are taking your mental model seriously, but also theirs, and doing that comparison. So it's really a very similar idea. And this power balance, this trust, this rapport is what creates that balance of assimilation and accommodation at a cognitive level, but it's displayed in terms of this kind of interaction. And there have been studies by Kruger and by, I'm just trying to remember the name. If you go back to my slide, you'll see. Asmitia and Montgomery did a study about friends versus acquaintances and how a level of transactivity and how that related to learning and math. So these studies have shown how these social factors do influence the flow of transactivity. Similarly, in our own analyses, we've seen that Other dimensions of our analysis of conversations that focus purely on social factors, they also relate to articulations of reasoning, and sometimes there isn't enough transactivity to see a correlation. So it's not always the most frequent kind of interaction. It happens with scaffolding. It happens in the best of cases, but we see more reasoning, at least, when we see kind of a balance of what correlates with self-efficacy in a conversation, and also showing openness, and so other kind of social signals. And so that's why we really think that there's a very strong connection between those things at a social level that we investigate and these cognitive behaviors like transactivity that we see in the argumentation.
So one more question. Last week, Art Gracer gave a presentation on his idea of trialogues, of having agents with different roles, promoting learning. And you've talked here a lot about learners employing, in different roles. What are your thoughts about agents taking on different roles in a collaborative learning context? And is there a common framework that you see emerging from these two lines of research, combining learners and agents?
So I definitely think that roles are valuable in group work. I think that in Art's work, it plays a kind of a different function. And I think that he uses the multiple agents in very effective ways in order to provide different perspectives to the one student. But I think that in my work, something that's been really important is the richness of the interaction between students. So even though there's a simulated group in the trialogues that Art is developing, I would say that it isn't collaborative learning in the same sense, that there's something that I'm going for in bringing multiple humans together that you get from having multiple humans, and you don't get from having multiple agents that are playing conversational roles. Nevertheless, I think very highly of Art's work, and I'm very familiar with the work that he's doing. And I do think that he uses those different roles in strategic and effective ways in those interactions.
Okay, well, I'm afraid we're out of time. So thanks again, Carolyn, for a great talk. And a reminder to everybody, next week we have another webinar coming up from Jack Mostow, who's going to be talking about the present of AI in education and training. He's done work in really making AI-driven learning systems available around the world, and has some insights on how to make it available in areas with more limited computing resources. I hope you will join in for that. So until now, we're at the end of our session. Thanks, everybody, and hope to see you next week.
Great. Thank you.
Bye-bye.